There is an entire side of the moon that no human being has ever seen from Earth. Not once. Not ever. In all of human history, every night you have looked up at the moon, you have only seen half of it. The other half has always been turned away. Hidden. And when we finally got there and saw what was on it, what we found raised more questions than it answered. So what is actually on the far side of the moon? And why does it look so completely different from the side we know? This isn't a conspiracy video. There's no cover-up here. But the real science of the lunar far side is genuinely strange. Strange enough that it has puzzled some of the best planetary scientists on Earth for decades. And most people have no idea what's actually over there, or why it matters so much for the future of space exploration. By the end of this video, you will. I've spent a long time digging into planetary science, space mission history, and the kind of research that never quite makes it into mainstream headlines. The far side of the moon is one of those topics where the actual facts are more interesting than anything anyone could make up. So let's do this properly. Here's the plan. First, we'll explain why the far side is always hidden, because the reason itself is fascinating. Then we'll get into what the far side actually looks like and why it is so shockingly different from the near side. After that, we'll cover what missions have gone there and what they found. Then we'll talk about the single most mysterious feature on the lunar far side. And finally, we'll look at why this hidden hemisphere could be the most valuable piece of real estate in the entire solar system. Let's go. So why can't we ever see the far side from Earth? The answer is something called tidal locking, and it is one of the most elegant gravitational mechanics in nature. When the moon formed, it rotated freely, spinning on its own axis the way Earth does. But Earth's gravity exerted a tidal force on the moon. It created a slight bulge on the side facing Earth, just like the moon creates ocean tides here. That bulge experienced a constant gravitational pull. Over millions of years, this friction slowed the moon's rotation down, and it kept slowing and slowing until the moon's rotation period matched its orbital period exactly. One rotation per orbit, 27 days to spin, 27 days to go around the Earth. Perfectly synchronized. The result, one face always points toward us. One face never does. This isn't sinister, it's just gravity being patient. But it means that for the entire span of human civilization, every culture, every astronomer, every poet who ever wrote about the moon, nobody had any idea what lay on the other side. That changed in 1959. The Soviet Luna. 3 probes swung around the moon and took the first photographs of the far side. The images were grainy. They were rough by modern standards. But what they showed was immediately shocking, and it has puzzled scientists ever since. The near side of the moon, the side you see, is covered in dark, flat plains called Maria. The word is Latin for seas, because early astronomers thought they were bodies of water. They're not. They're ancient lava flows, dark basaltic rock that erupted billions of years ago and flooded the low-lying basins. They give the moon its familiar face, the man in the moon shape, the dark splotches you can see with the naked eye. The far side has almost none of that. The far side is almost entirely pale, heavily cratered highlands, a relentless, battered terrain of craters on top of craters. Billions of years of impacts with almost no volcanic resurfacing to smooth things over. Scientists call it the lunar dichotomy, 2 faces of the same moon looking almost nothing alike, and nobody fully agrees on why. The leading theory involves the early solar system, a time called the Late Heavy Bombardment, when asteroids and debris were slamming into everything at a ferocious rate. One hypothesis suggests that in the moon's very early history, Earth's tidal heating may have kept the near side warmer, making its crust thinner and more susceptible to volcanic activity. When heat from the lunar interior pushed up, it broke through the thinner near-side crust more easily, flooding the basins with lava. The far side's crust was thicker, cooler, and held, so the craters stayed. The difference in crustal thickness between the two sides, confirmed by orbital data, is real and dramatic, but the exact reason for it is still being researched. Another theory, and this one is genuinely wild, suggests that Earth may have once had a second, smaller moon, and that second moon eventually collided with the lunar far side in a slow, low-speed impact that piled extra crust onto it, thickening it and suppressing the volcanism that reshaped the near side. There is actual modeling behind this idea. It has not been disproven. The moon may have eaten its sibling. Can we pause on that for a second? The moon might have consumed an entire second moon billions of years ago, and the scar of that collision is the mismatched hemisphere we can never see from Earth. That is not a small idea. Now, let's talk about what missions have actually gone there. Reaching the far side is genuinely hard. You can't communicate directly with a spacecraft on the far side. Earth is blocked. Any signal has to be relayed. For decades, that barrier kept landers away. Orbiters could photograph it, but nobody landed. Until January 2019, when China's Chang'e 4 mission made history, the first ever soft landing on the lunar far side. It touched down in the von Karman crater, inside a region called the South Pole Aitken Basin. And it brought a rover called U-22, which is still operating today, making it the longest-running lunar rover in history. Chang'e 4 used a relay satellite called Queqiao, positioned at a gravitational equilibrium point beyond the moon, to bounce communications back to Earth. An elegant solution to an old problem, and the science it has returned has been extraordinary. U-22 has found evidence of mantle material exposed on the surface, rocks from deep inside the moon, thrown up by ancient impacts, now sitting on the crater floor waiting to be studied. Material that could tell us how the moon formed and what its interior looks like. And that brings us to the single most extraordinary feature on the far side of the moon: the South Pole Aitken Basin. Say it slowly. This is not a small crater. This is one of the largest confirmed impact craters in the entire solar system. It is approximately 2,500 kilometers across, and it is 8 kilometers deep. To put that in perspective, it is roughly the size of the continental United States. It was created by an ancient, catastrophic impact so enormous that it punched through the lunar crust and exposed material from the moon's mantle below. Scientists consider it one of the most scientifically valuable places in the solar system. The rocks at the bottom of that basin are ancient, possibly among the oldest accessible rocks anywhere we could reach. Studying them could answer fundamental questions about the formation of the moon, the early solar system, and the processes that shaped every rocky planet, including Earth. Multiple missions from NASA, China, India, and others are targeting this basin, specifically in the coming years, and here's the final piece. The one that makes the far side not just historically interesting, but strategically critical right now. The far side of the moon is the quietest place reachable by humans. On Earth, we are drowning in radio frequency interference, from phones, satellites, broadcasts, Wi-Fi, everything. Even in the remotest locations, the electromagnetic noise of civilization bleeds in. On the lunar far side, Earth itself blocks all of that. The far side is shielded, naturally, permanently, from every human radio signal. It is the only place in the near solar system where a radio telescope could listen to the universe in true silence. Astronomers have dreamed for decades of placing a radio telescope on the far side of the moon. it would be able to detect signals in frequency ranges that are completely inaccessible from Earth, including the frequencies that some researchers believe might carry signals from the very first stars and structures of the early universe, signals we literally cannot hear from anywhere else. The far side of the moon might be the key to unlocking the universe's earliest chapter. That is what is over there, not secrets, not cover-ups, something much more interesting, a geologically alien hemisphere of our own moon, shaped by forces we are still untangling, hosting the solar system's most scientifically valuable crater, and offering a window of silence into the deepest past of the universe. Let's bring it together. The far side is hidden because of tidal locking, elegant gravitational mechanics, not conspiracy. It looks radically different from the near side, heavily cratered, almost no volcanic plains, and nobody fully agrees why, though the leading theories involve crustal thickness differences and possibly a second ancient moon. Chang'e 4 landed there in 2019 and is still returning science today. The South Pole Aitken Basin is one of the largest impact craters in the solar system and one of the most valuable scientific targets anywhere we can reach. And the far side's natural radio silence makes it the ideal location for a telescope that could hear the universe's very first light. Now I want to hear from you. What surprised you most? The tidal locking mechanics? The second moon theory? The sheer scale of the South Pole Aitken Basin? Or the idea of a radio telescope in lunar silence? Drop it in the comments. I read every single one. And if this got you curious, I've got a video on the James Webb Telescope's most shocking discoveries, a perfect companion to this one. Because Webb is doing from space what a lunar far-side telescope could one day do from the moon. It's right here. Until next time, the moon has been staring at us for billions of years. It's about time we stared back at all of it.